Good morning. Today I am presenting my project on securing IoT data using machine learning and cryptography. This project focuses on how IoT data can be processed using AI and how that same data must also be protected using modern encryption methods. IoT devices continuously generate sensitive personal and environmental data. The problem is that the most IoT system analyze this data using AI without proper security, which leads to risks such as data leaks, surveillance, and unauthorized access. The main aim of this project is to compare an unsecured AI model with a secured AI model and analyze the impact of applying cryptography. The objectives are to pre-process IoT data, to train a baseline ML model, to apply encryption to the dataset, and to evaluate security versus performance. The Internet of Things refers to physical devices connected to the Internet that collect and transmit data using sensors. Examples include smartwatches, smart homes, medical sensors, and surveillance systems. IoT is important because it enables real-time monitoring, automation, and data-driven decision making across industries like healthcare, smart cities, and cybersecurity. Despite its benefits, IoT suffers from major issues such as weak authentication, unencrypted data transmission, limited processing power for security. This makes IoT systems highly vulnerable to cyber attacks. IoT security is needed to protect user privacy, device integrity, and system availability. Without security, IoT networks can be hijacked, manipulated, or used for cybercrime. The CIA triad consists of confidentiality, integrity, availability. Our secure model directly enforces confidentiality and integrity using encryption. We used two datasets, a public IoT sensor dataset in CSV format and an Apple Health XML dataset which has converted into structured data. These datasets contained sensor readings used for machine learning. In pre-processing, we removed unnecessary attributes, normalized the data, selected only meaningful sensor features, and removed incorrect labels. This step is required to improve ML accuracy. Model 1 is the baseline AI system without encryption. It uses a random forest algorithm for prediction. The dataset is loaded in plain form and directly used for training and testing. Model 1 achieved high accuracy and fast performance. However, all data is exposed in readable format. This means it is not secured for real-world deployment. Any attacker can read the data set, modify the values, or steal sensitive information. Therefore, Model 1 is only used as performance benchmark. Model 2 applies cryptography before machine learning. The dataset is encrypted using AES encryption with Fernet. The encryption key is generated using PBKDF2 with SALT and SH8256. Only when the correct password is provided, the encrypted dataset is decrypted and loaded into memory. Without the correct password, the model cannot access the data. Model 2 shows a slight performance drop due to encryption overhead. However, the dataset is now protected against theft and tampering. Model 1 offers speed but zero security. Model 2 offers strong security with only a small loss in performance. For real-world applications, Model 2 is the correct solution. The graphs show how different IoT features influence predictions. They also compare prediction errors before and after the encryption. This system can be applied to smart healthcare monitoring, secure wearable devices, smart surveillance, private home automation systems where user privacy must be preserved. IoT data directly affects user privacy. If misused, it can lead to surveillance and profiling. Therefore, encryption and transparency are ethically required. This project is currently limited by use of symmetric encryption only, no real-time streaming, and limited dataset size. In future, this system can be improved by adding RSA key exchange, deep learning models, blockchain-based IoT security, and real-time anomaly detection. This project proves that AI can analyze IoT data effectively, and cryptography can protect that same data without destroying performance, security, and AI must work together in future AI IoT systems. All references used in this project are listed here and follow academic standards. Thank you.